Hi, we are students from Aswin College of Engineering, belonging to the Department of Biomedical Engineering. I myself Aswin and he is my team member Gopalakrishnan. And we are working under Associate Professor Dr. B. Mahesh, belonging to the same department. This current project, the project which we have submitted to NIANTRA, titled Development of EOG based assist devices, is currently mentored by Mr. Chennai Mishra from NI. We had already shared the videos which depicts the initial work done by us for the past 2 months. In this video demonstration, which we will be showing shortly, it will deal about the work which was done after the videos which was shared initially, and it will explain about the modules completed as mentioned in our proposal. In the outset, this current video demonstration will involve 2 modules to be explained. That is, the modules which were completed after for the current month. In the first VI, that is, the subject will be able to control the keyboard cursor for folder navigation and selection. And in the second VI, which involves the same concept, the person will be able to move the mouse pointers as per his gaze, and he can perform the equivalent action of click by blinking. So what we did was, we integrated everything. We integrated the existing on-screen keyboard in Windows 7 with that of the VI, and the person will be able to select the characters in the on-screen keyboard, and by blinking and by navigating in the respective direction. So once the entire message has been typed, that is, once the message has been entered, once he presses the enter key, the typed in message will be serially transmitted to a interface GSM modem, and hence the message gets delivered to the recipient, and the recipient's mobile number will also be programmed, or the subject will also be able to select the recipient's mobile number. So we will be showing this demonstration now. Thank you.
In this VI demonstration, the shown VI is used for keyboard cursor movements as per the directional eye gaze of the subject. The EOG 2-channel EOG data is acquired initially through a DAC, and the 2-channel data is split up using a signal splitter, and it is fed to the respective peak detectors. Peak detectors will look for peaks or valleys and produces an output pulse. If a peak is found either in the positive axis direction or a negative axis direction, that is, it classifies the right, left or up and down signal. Once a respective event, say a write, has been triggered, it will trigger a case structure which has the equivalent action, key call library function, DLL call libraries, and which has been sent a parameter of 39. 39 is used for write action, and we will be sending this parameter to the DLL function, so that whenever this case structure gets triggered, if the person looks in the right direction, the equivalent action of the right arrow key press is being done. Similarly, we have case structures for left, right, up and down. We have 4 case structures, and we have a separate case structure for enter pulse, for which we send the parameter value 13 to perform the enter action. Now, this section is used to classify the up and the blink signal. We know that the blink signal is a short negative going pulse, whereas an up signal is a low amplitude negative going pulse. So in order to distinguish, whenever a person looks or blinks, he will be getting an up signal also. So in order to extract the blink component from the up signal, we employ another threshold value to detect the blink amplitude, and we finally incorporate a AND gate, so that when a person blinks, a 1-1 occurs for both up and the blink action, and finally the output is 1. So if it is 1, we will be triggering the enter DLL function. If the person blinks, if the person looks in the up direction, which is a low amplitude pulse, it won't trigger the blink signal. That is, since the blink threshold is far beyond than up signal threshold. Hence, it will be a 1-0 combination and the output of the AND gate will be 0, which means that the entire DLL function doesn't get triggered. So, for up signal, you can have only the up arrow key pressed, and if the person blinks, there will be only a blink action that will be performed, and there won't be any up action performed. So this is all with regard to the keyboard cursor movements by the directional eye gaze of the subject. Now let's move on to the explanation, VA explanation for mouse cursor movements.
Now let's move on to the first demonstration. In this demonstration, the subject will be able to control the keyboard cursor by gazing in the respective direction, and he will be selecting the folder by blinking. The subject is Gopalakrishnan, and there are 5 electrodes placed around his eye. The first electrode is the electrode for the vertical component. This set, one above the eyebrow and the other below the eye, and for horizontal component it is placed on the other segment, left and right, for getting the left and right segment, and the reference electrode is also placed. Now let's move on to the VI. Currently you can see the signals getting acquired, and the first one is for the top one is for left and right, and the bottom is one for up and down signals. I'll give directions for the patient, and he will be able to see the signal variations. Left, right, left, right, left, right, left, right. Now you can see the horizontal component variations. Further, we will show the vertical component variation now. Up, down, up, down, up, down, up. So, hence, these signals are acquired and converted into control pulses, and when the person blinks, he will be able to select the folder.
We'll show the blink component.
Yeah, the blink component will be shown in the folder selection. Okay, now the VI is running on the back, and we have the folder selection right over here. Okay, right, left, left, right, down, down, left, blink. As you can see, if the person has blinked, the folder got opened. Blink again. Again, the folder has opened. Right, right. Now the person is selecting the folders, interacting with the folders by means of giving his gaze in the respective direction.
Down, down, down. No down folder there. Up, 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 left, 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 no left
No
folder
left
there.
folder.
Up, left, 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 left,
blink.
blink.
So the person has selected the folder now. We will show the VA that's running behind. As you can see, this was the left and right signals, and this was the up and down signal. I will give directions to the subject, and those are the amplifiers that has been used. We use a NA DAC to acquire the signal. Left, you can see the left pulse. Right, you can see the right pulse. And for down, you can see the down pulse. And for up, sorry, he has done down. Up. Yeah, you can see the up, negative going pulse. We have set the suitable thresholds here, and also the blink threshold. So those LEDs indicate the up, down, right or left. So again we'll move on to the folder, and you can see the variation. You can see the picture folder. It can be better visualized for picture folders. So I'm placing this. Okay, left, blink. So you can see the picture got open. Left, yeah, left, blink again. Right, good, right, good, left, good, blink. As you can see, the person has selected this folder, picture. Again he will be able to navigate through the screens. Right, 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 left, good, left, good, right, good, right, good, left, left.
No left pictures here.
There are no left pictures there. So again the person is directed towards his right. Oh shoot, right. Good. Left. Good. So thus, now the shown VI is the mouse cursor control VI, which has the same structure as that of the keyboard VI, but there's a small difference. Instead of using the instead of using the keyboard DLL libraries, we use the mouse DLL libraries, and we specify the amount, and we have 4 libraries as such for performing the left, right, up, down movement of the mouse pointer. And these 4 DLLs are parameters such as value, that is the amount by which the mouse pointer should move, is also specified to each DLL function. Finally, you have also a click DLL, which performs the right click action. So whenever it gets triggered as per the blink action of the subject, and rest of the functioning of the VI is exactly similar to that of the keyboard cursor movements. And we have peak detectors employed for both up and down, and an AND gate to distinguish between the up pulse and the blink pulse. So whenever the person looks in the respective direction, you can have the movements in the